Hello everyone, this is Mr. Osama, Math Department, Sunrise English School. Today inshallah we're going to talk about the chapter 5 lesson on geometry for grade 8, which is called the midsegments of triangles. The midsegments of triangles. First of all, we need to understand what is the meaning of the midsegment. Then we need to know how to use the midsegments for getting some information from the exercise or to solve the exercise. First of all, we need to draw a regular triangle here in this is part. So I'm gonna graph a regular triangle and highlight it, the midsegments. So I'm gonna name it by ABC triangle, ABC triangle here. A, this is A, and the other vertex will be B here, B, the other vertex will be C, which is the triangle ABC. Triangle ABC. We need to highlight the midsegments, so I'm gonna use the red color to identify the red segments, which is gonna be here. I'm gonna draw a midsegment between this is two sides here. I'm gonna label it by D and E, the segment D and E. So right now we draw a triangle ABC. This triangle has DE, red segments is gonna be midsegments. So what is the definition of the midsegment? We need to write down the definition of the midsegments first. The definition of the midsegment can be written as the midsegment is the segment that connecting two midpoints of the two sides of the triangle. Again, the definition of the midsegments of a triangle, the segment that connecting the midpoints of two sides of the triangle. So I'm gonna write down the midsegment definition. So midsegment, I'm gonna use the regular midsegment. Midsegment is, we need to maximize the, we need to write here, the midsegment is the segment or is a segment connecting segment is a segment that connecting the midpoints, of two sides of the triangle, of two sides of the triangle. According to the definition which we have right now, I'm getting back to the triangle ABC. D is a midsegment of the side AC, and E is a midsegment of the side CB. I need to highlight this, so I'm going to use a different color to make it easy for you. So I'm going to use the blue color here. This segment is, this segment which is segment is congruent to this segment, and this is segment was congruent to the segment EB. So according to what we had right now, the definition of the midsegment ABC is a triangle D is the midpoint of the AC, E is the midpoint of the BC, then the DE will be the mid-segment of the triangle ABC. We need to get back to the definition of the mid-segment. The mid-segment is a segment that connecting two midpoints of the triangle's sides, which has been illustrated in front of your eyes right now. So what is the theorem? We need to have the theorem of the mid-segments which we are looking for. The mid-segment theorem, which is theorem number 5.1 in our student book. So I'm going to write down here the mid-segments theorem, which is here. We need to go back here, the mid-segment theorem. So the mid-segment theorem, which is 5.1, the mid-segment theorem states that if a segment joins midpoints of two sides of a triangle of a triangle then the conclusion, what is the conclusion? Then the segment will be will do two things, or we get two conclusions from this is a definition of this theorem. The first conclusion will be the segment will give us two things. The first one, the segment will be parallel to the third side, so the segment will parallel to the third side and half as long, and it will be half of its length. So the segment, which is DE, will be parallel to the segment AB, which is the third side, and equals its half of length. So it's gonna be equal and it's half as long, and it's half of its long, and is half as long, and is half as long. What does it mean? It means that the segment DE, so DE segment will be parallel to the third side, which is AB, and equals half of its length. So DE is the mid-segment of the triangle. Which is ABC. Now we're done with the definition of the mid-segment and the mid-segment theorem. We need to move forward to the next part of our lesson, which is how to use the midpoint formula. Sometimes we need this formula to help us for find some coordinates or distance or length or whatever. So the next point is how to get the midpoint formula. So I'm gonna go up a little bit, move this up, and I'm gonna write down the midpoint formula here. So I'm gonna write down here the midpoint formula, the midpoint formula. The midpoint formula, it's gonna be easy to write it down. So the midpoint will be for any 2 points. Say that I have segment here, and this segment is AB, for example, segment AB. So I'm gonna write down here segment A and B segment, and this is segment AB has a length whatever, and the A has a coordinates of x1 y1. This is A, it has a coordinates x1 y1. And the B has a coordinates as well x2 y2. How to find out the mid segments, which is M? I'm gonna highlight it here as M, and M will be the midpoint of the segment AB. So I'm gonna write down the mathematical formula for M, which equals the sum of all for the midpoint coordinates is gonna be the x coordinates will be the sum of all x's divided by 2, and the coordinates of y will be the sum of y's over 2. So I'm gonna use the fractional form. I'm gonna use a fractional form to write down this. So it's gonna be here. This is x1 plus y x2 over 2. So I'm gonna cancel this out and write it back. Sorry. So here it's gonna be, here I'm gonna write down x1 x1 plus x2 all divided by, so sorry, back again. So I'm gonna write down again x1 plus x2. This is will be divided by, I'm gonna take a fractional line, divided by 2, and for the y will be, for the y it will be y1 plus y2 this is will be as well divided by 2, and this is will cover the midpoint of the segment AB, will cover the mid segment coordinates of the segment AB. So right now we got the definition of the mid-segment, which is coordinates it's x1 plus x2 over 2 and y1 plus y2 over 2, and this will cover the mid-segments formula. So we can use this in the future to find out the coordinates of the mid-segment. The coordinates of the mid-segment. So we need to close this as parentheses. So I'm gonna do it manually here. This will be the coordinates of the midpoint, which is x1 plus x2 over 2 and y1 plus y2 over 2, and this will cover the mid-segments formula. Next, now we need to have some exercise to apply the theorem 5.1, which is the mid-segment theorem. How to use the theorem for finding out some information. So I'm gonna move up a little bit to get a new question, or the first question for this lesson. So I'm gonna move up a little bit. I'm gonna draw a triangle, example number 1 here. So I'm gonna write down example number 1. Exercises number 1. The exercise number 1, I'm gonna draw a triangle. I'm gonna draw a triangle here, and we need to find out what is going on. So we need to have some kinematical condition to understand what if the triangle goes. So I'm gonna draw a segment here, use the color, red color, to draw a segment, and this segment starts from here to there. Sorry, I have to get back to make it smart. So here is gonna be segment, and this segment has a length of, he gave me some kinematical condition that this segment is the mid-segment of the triangle, so this is equal to this segment, and this segment for the other side is equal to that segment there. So here, this is segment which is the mid-segment of the triangle. So this is length is 72, the largest length. I'm gonna highlight it here. This is segment, it's gonna be 6x, length 6x, and the length of that side is 72 unit, and the question asked you to find out the value of x. So here we are going to solve for x. Example number 1, solve for x. Example number 1 here, you're gonna solve for x. Solve for x. How to solve for x for this example? I have to use the mathematical formula, or the theorem 5.1 which we had. The theorem said that if a segment is a mid-segment of the triangle, then this segment will be parallel to the third side, and it's equal to half of its length. It's called the half of its length. So I'm gonna say that 6x, this is a mid-segment, equal half of 72. So I'm gonna say here, since the segment which is 6x is a mid-segment, then the conclusion will be, is equal to 1 over 2, or half of 72, which is the third side. So I'm gonna establish an equation, 72 multiplied by or divided by 2, 72 divided by 72 divided by 2 or half of it, or equal to 2 times 6x, the same meaning, 2 times 6x. So 72 is gonna be equal to the same meaning, 2 times 6x, and you close the parentheses. Then you're gonna solve for x. So I'm gonna divide it both sides by 2. I'm gonna divide it here by 2, divide it here by 2. So I'm gonna divide it both sides by 2. Divided by 2, and we'll get the answer. I'm gonna use the method 2 divided here by 2, divided here by 2. The result will be 72 divided by 2. I'm gonna use my calculator to get this. Sorry, I made here a little bit mistakes here. This is some 2's here is not supposed. Here, this is one's not supposed to be there. This will be cancelled. So I'm gonna divide it here by 2, divide it here by 2. So I'm gonna write down the answer will be 72 divided by 2 is gonna be 4. So I'm gonna use the calculator. 72 divided by 2, the result will be 36. So the left hand side will be 36 equal 6x. Then you divided all sides by 6 again, the result will be 6 equal x. The value of x here, x equal 6. And this will be the answer for the question which we had right now, question number 1. We need to have another example for the same session, which I'm gonna draw another example here. Example number 2, exercise number 2. We need to draw a triangle again. So I'm gonna use a triangle here. I'm gonna draw a triangle. This triangle has some kinematical conditions. Triangle has a kinematical condition, and this is segment. It has to be x here. So I'm gonna write down here x. And the other side, or the third side, will be 26. It's going to be 26 length unit. So the question asked for me to find out the value of x. How to find out the value of x. We find out the value of x. To find out the value of x, we need to use the theorem which we had right now, that the midsegment. I forget to write down here the segment. This segment is congruent to this segment, and this segment is congruent to the other one. So this segment stands for the midsegment right now, which is illustrated by x, and the third side, which is 26, is the third side opposite to this one. So x is half of 26. X is half of 26. So I'm gonna see here x equals 1/2 of 26. So I'm gonna say x equals 13, and this will cover the answer for this question. So right now we apply the theorem, and inshallah we will continue to have some exercises later on. But today I think we finish with the definition of the theorem and how to apply it. And inshallah in the second video, or in the next video, I'm gonna talk about some exercises to help you out for solving this type of question. Thank you for watching the video, and I hope you got everything clear. Thank you, and have a good day. Goodbye.